Hello, everybody. Thank you very much for joining our session today. I'm delighted to be here with Emily from the Fluigm team, who is our field application specialist and who is running this mass cytometry masterclass today. So just before I hand over, I would like to let you know that during the presentation, you can ask all your questions in the question box that's on the right-hand side of your screen. And we will pick them up at the end of the session during a short Q&A. So if you would like to book one-to-one with Emily, there is still some space. I will put the link in the chat, and you can click on the link and book yourself in if you would like to discuss a project a little bit further on a one-to-one basis. So just before I let Miguel and Senan talk to you for a bit, I have a couple of poll questions to ask you. So could you please answer that question? Do you have any experience with mass cytometry or imaging mass cytometry? And you just need to click the answer that best applies to you. So thank you very much. So I'll close that. And the second question is, what range of markers are you interested in looking at? Is it 1 to 10, 11 to 20, 21 to 30, 31 to 40, or 40 plus? So I'll give you a few more seconds, guys. Thank you so much. So I'll quickly share the results of those two questions with you guys. So basically, for the first question, we had a third of the people who use both Helios and Hyperion, and 2/3 who haven't used any of those. So be sure you will learn a lot today. And regarding the other question, we have a third of you guys who look at markers from 21 to 30, another third of you 31 to 40, and the other third 40 plus. So Emily, I hope this helped you.
Yes.
All right, guys. And also before I go, this session is being recorded, so we will send you the recording in an email in a few days, and then you can feel free, to share it with your colleagues that have missed the session, or watch it again if you like it so much. Thank you very much, and Miguel and Senan, it's to you now.
Okay, welcome everybody. My name is Miguel. I'm in charge of the Flow core facility here at EPFL. Welcome to this Mass Cytometry Masterclass, the second edition. After the introduction to Mass Cytometry, we have the pleasure to have Emily talking about tips and tricks. I'm sure will be really useful for all of us. If you need some more information about the Flow core facility, I invite you to go to our website that you can easily find if you Google EPFL Flow Cytometry core facility. And if you have need more information about the mass cytometry side of the core facility, for sure Senan will give a short introduction just after me. Thank you very much to Fluigm to collaborate with us. It's really a pleasure also to organize these sessions for us. And I wish you a wonderful presentation. Senan, the floor is yours.
Okay, hello everybody. Hope you will enjoy this masterclass. You can email us at cytop@epfl.ch if you're interested to understand more, if you have any questions. Emily, the floor is yours.
Thanks. So, yes, thanks to all of you to be there today. Thanks to Miguel and Senan to ask us to do this masterclass, and I hope it will be really useful for you. So the aim of this presentation will be to have the keys to success in your mass cytometry experiments. So just before I will do a little quick overview of the mass cytometry. As you said that in the poll question, some of you don't have any experience with the mass cytometry. So So the mass cytometry is now a well-known technology. It's cytometry above all, and it allows you to study more than 50 parameters at the same time on one single tube. So this is possible by using antibodies tagged with metal. And it's super useful if you look at precious sample, for example, because you can have a lot of information in just one tube. So how it is possible to have this amount of parameters? So as you can see here, the detection is based on the mass of the metal and not on the fluorescence of fluorochromes. And you can see that here, I will put my laser pointer. So you can see here that the signal are really separate and distinct. So we can have a lot of markers in the same time. So as you can see here, we have a range of detection of more than 100 channels. And you can see that now we can study around 50 parameters, but in the future we can increase this number. So one of the advantage of the mass cytometry is the fact that there is not a lot of variation between the intensity of the metal. It's not like for fluorochromes. Sometimes you can have up to 1 log of difference between 2 fluorochromes. Here you can have 2 times or 3 times difference between 2 metal tag maximum. Another big advantage of the mass cytometry is the fact that you have no autofluorescence because you look at the mass of the metals and not the light of the fluorochromes. So you will not have any interference of the autofluorescence of your cells. So it could be natural autofluorescence or induced autofluorescence when you do, for example, like intracellular staining. So a quick overview of the principle of the mass cytometry. As I said before, mass cytometry is cytometry above all. So you have a suspension of cells. You have to stain your cells with antibody. Here, the antibody are tagged with metal isotopes. And after that, all your cells will go through a plasma that will ionize all your cells. And after the plasma, you will have an ion cloud. So each cell becomes an ion cloud. And this ion cloud have to be filtered to just keep the EV metals that are really interesting. And when we have this clean ion cloud, we can separate the different isotopes thanks to a mass spectrometer with a time of flight chamber, a TOF chamber. And here you will have a separation of the different metals based on the size of the metal, the mass. So you will have the little one coming at the before and the bigger one coming after. So each time a metal hit the detector, you will have an integration of the signal in a FCS file. So it's a classical FCS file. And you can analyze this FCS file with cytometry analysis software, the one that you want. So the aim of the talk today is to maximize your results in mass cytometry, so decrease all the struggle you can have and improve your success. So for that, we will go through different steps of the preparation of your samples. And you have to know that all the things I will explain today are not official recommendations, but are really used and useful for mass cytometry. So a lot of customers are doing that, and you will see with these little tips and tricks, you will success in mass cytometry. So the first steps are the consumables and the buffers that you will use in mass cytometry. You have to be really careful at these steps. So the first thing to do is always use filter tips. The advantage of the filter tips is to really prevent contamination of your pipettes. So mainly when you pipette metals, when you do a homemade conjugation, you will pipette directly the metal. So using filter tips will prevent contamination of your pipettes and after contamination of other samples, of course. Another thing to do is always using polypropylene plastic and tubes because when you resuspend your cells for the acquisition, the cells are really electrostatic, so they will stick to the plastic of the tube. So with polypropylene tubes, you will decrease this effect. Another thing really important is the buffer that you will use have to be really pure, I would say. So you have to be sure that there is no contamination inside. The best option is to use the Fluigm buffer regions because we do quality control in our house. So we know that all the buffers that we propose are really clean with no contamination. But if you want to use your regions, it's still possible. You just have to check that with the core facility. So just ask Miguel and Sena, and you can find a way to test your regions if you want to use it. So the different contamination can come from everywhere because the metal that we are looking at are really metal on the crust of the earth, so you can have a lot of barium everywhere, so just be careful of that. And yes, something really crucial, always keep your bottles closed because, as I said before, barium is everywhere and it's in the air, so if you let your bottles just open, all the barium and contaminant can go through your bottles. And one last thing is don't use autoclaved consumables because it's not the autoclave itself that induces the contamination, but there is an O-ring inside the autoclave that can release some metals. So just be really careful with autoclaved consumable. It's better to just forget autoclaved consumables. So now we will see really quickly some of the contaminants, possible contaminants. So the first one is the lead. The lead is present in glassware. So be careful to always keep your reagents in plastic bottle and not in glass bottle. Another one is the barium. The barium is the most common contaminant in mass cytometry. You can find the barium in detergents, so be careful to rinse. It's mainly for the core facility operator, I would say, because a lot of parts of the instrument are cleaned with detergent, so they have to rinse with water. But you can find barium somewhere else. You can find the barium in latex, for example, so please don't use gloves in latex. And you can also find it in different buffers like PBS, for example. So if you don't want to use the MaxPar, the Fluigm PBS, you can use PBS without magnesium and calcium. So we know that this kind of PBS have low barium and low cesium contamination. Other things to use, the water. If you don't want to use the water from Fluigm, use molecule water. It's super pure. You can use it for your mass cytometry experiment. There is no issue at all. And after that, be just careful of the background of the samples of the patients. If you are working on human samples, for example, or even in mouse samples sometimes, just be careful of the background of the mice or the patients. Sometimes they can just be treated by some reagent like cisplatin from chemotherapy or some contrast dyes for imaging, for example. So just be careful of that and let your core facility know if some of your samples may have this contaminant. Another contaminant is the iodine. the iodine, you have to know that the fecal, for example, contain iodine. So if you are working on PBMCs, just be careful to well wash your cells after cycle. Okay. So what it is important to avoid contamination. So this is a rain plot. This is the way the mass cytometer will determine your cells, identify your cells. So you can see is here one line is one cell. So you can see here the different channel open, and the software of the Cyto will say I need to have a little bullet like this to define an event. And you need to have some things like really empty between two events to define the events. If you have a contamination like this, for example, with a lot of barium inside, it will not be able to define your events. So the issue here is that all the events here will be just they will just exclude of your FCS file. So you will have a FCS file with no cells because it can't define the cells. And another issue is that even if we manage to get some of the events, you will have a decrease of the signal because your detector have too much metal that can, and you will just bleach your detector, and you can have a decrease of your signal. So just be really careful with contamination and always check with the core facility before acquisition. So now we will have a look at the preparation of your samples. So first of all, we will look at the source of your sample. So before experiment, you have to know a lot of things just to be sure that everything will be okay. So just be careful if your patient or mice have been treated. Have we seen before? So for example, if you have a patient treated with cisplatin, just be careful because cisplatin can be used as a live dead stain. So just choose another live dead stain like rhodium, for example, and be careful that this treatment is not too high and you will not, that will not impact your results. Another possibility, do you use fecal or not? Is it okay? But normally, don't be worried. PBMCs are okay. If you wash well yourself, there is no issue. And after that, you have to think about if you use tissue, think about the dissociation of your tissue, the way that you dissociate it, and what it could impact the epitopes, for example. And always think about the amount of cell you want to have at the end during the acquisition, and just size your experiment in regard to that. So, and now we can work on different type of cells like adherent cells, suspension cells, or tissues. All of these kind of cells can be used there with no issue because we are once again in cytometry. So if you can work on cytometry, you can work on mass cytometry with your sample. Just be careful if you are working on tissues, be really careful of the digestion. So you know that some type of digestion can affect some epitopes of your cells. So just be really careful and adapt your digestion to your tissue. So there is a lot of literature about that. So if you have more questions, do not hesitate to contact us or contact your core facility. I'm sure they have some tips also for that. And something really important, just if you are not sure of the digestion process to use, look at some crucial markers, I would say, like CD56 or CD127 in human, that are really sensible to digestion, or some other markers for mouse, like CD62 ligand or CD27, that are really sensible to the digestion. So if you lose these markers, that your digestion is not optimal. So you can optimize your digestion to improve your staining. And yeah, never just think that if you have a lot of clogs and lot of dead cell that are released during this disruption, use DNAs. That will avoid a lot of clumping after. So now you can work on fresh sample or frozen samples. So it depends of the source of your samples. So if you are working on frozen samples, just treat them like tissue. Be really careful. You can, if you want, rest your cells after thawing. So in this case, use always a buffer with protein. So it will be better for your cells and you will have a better recovery. And after that, just be really careful of the amount of the debris. So check always your sample after thawing under a microscope. Always confirm that cells are at a single cell suspension, so that you have not a lot of clumps. And if you need it, use a DNase or benzonase to avoid this clump. So normally when people are working with frozen sample, they do automatically a DNA. So in this way, it's not super long, and you can do steps of DNase and resting in the same time at 37 degrees, and your samples will be better, and you will have less clump during the acquisition also. So always count your live and dead cells. If you are more than 80% of always use your samples with more than 80% of viability. So if you have less, it's better to avoid the staining, because you will have a lot of clumps and the staining will be not so good. So if it's a super important samples, I can understand, just check with your core facility, with Miguel and Sinan, to see if it's okay for them to do that. If you know that your sample is super sticky, just filter your samples before the staining. It could really help to decrease the clumps after that. And yes, just always keep in mind that if your sample is bad at the beginning, it will be bad at the end. So it's the garbage in, garbage out. So yeah. The preparation of your samples is really critical for the results at the end. So why the debris are super annoying in mass cytometry? I think it's the same in cytometry, the classical one. If you have debris, you will have a diffuse signal like here, and you can also have some debris sticking to your cells. So you will have some signal that don't come from your cells, but come from your debris, and you will have some weird signal in T cells. Maybe you can have a B cell marker, something like this. So it's super important to avoid the more debris you can. So the sample preparation is key here to decrease the debris. And if you have too much debris and you cannot do anything during the preparation, try to spin with a slow speed, so you can, like this, eliminate debris. But be careful, because you will also lose some cells. So yeah, it's a really if you can't do anything else. So now, be careful when you preserve your samples. So some of your cells will be sensitive to cryopreservation. So sometimes you cannot work on frozen samples because you want to look at some of these cell types like plasmablast or granulocytes or things like this. So in this case, you will prefer to stain before and preserve after. And it's the same for fixation. So sometimes you can just receive fixed samples, and you will see that some of the epitopes are affected by this fixation, like the CCR, for example. And also in this case, you will prefer to do the staining first and fix after that. So always be conscious of your samples and what you want to look at in your samples. Some tricks if you want to do your staining on sensitive cell type, or if you want to study some sensitive markers. So stain before on fresh sample and then preserve. The one thing really useful in mass cytometry is the fact that the metal are really robust, so you can freeze and fix your cells after staining. So it's super useful because in this way you can just stain your sample, fix them and freeze them and just acquire later, or do the intracellular staining later also. So there is no issue with that. Just be really cautious and don't do too much freeze those cycles. So if you do that, you will have a decrease of your staining, as you can see here. So one cycle is okay, but if you do more, you will just lose some of your staining. Be really cautious with that. And now the staining. So now you decide which sample to use, how to process it, and now we will go to the staining itself. So before the staining, you have to design your panel, the panel you will use. So for that, just always check your panel with the core facility or with us if you want, but always ask for a check before going through your experiment. So to design a panel, it's the bases are the same that in classical cytometry. You have to design your panel regarding the expression of your marker and the intensity of your tag. So for that, we have a tool that is the MaxPart Panel Designer. So you can have access to this tool. It's an online tool, and it helps you to do this design. So you have to know that in mass cytometry, the panel design is super easy, I would say. It takes few hours to do a 30, 40 marker panel. So it's quite easy, but you have to know some keys. So if you want to have more information about that, do not hesitate to contact us or your core facility. They can help you to do that. So it's super easy, I would say, because we know the spillover that we can have. It's something really known and consistent. And the aim of the panel design is really to minimize this spillover, to have optimized signals. So this spillover can come from 3 different things. The impurity, because the metal that you are using are not 100% pure. So sometimes you can have a little bit of another metal in your metal. As we can see here, we use the 146 gadolinium metal, and you can see that there is a little bit of the 145 gadolinium. So you will have a little bit of signal here, but it's not a big issue if you know it. So for example, if here in 146 you have a CD45, for example, you will have a strong signal, and you can have a little bit of signal in 145. If in 145 you have a high express marker like CD4, for example, it will not be an issue because both are really high intense, and the little bit of crosstalk of spillover will not impact your signals. Just keep in mind that the percentage of impurity is really, really low. But if you have here in 145 PD1, for example, this marker is super low expressed. So now you have to take into account that you will have this contamination, and just think about that. So it's not the mass cytometry is not you take the marker that you want and you put in the channel that you want. You have to think a little bit about that. But to be honest, it's quite easy to do that. And yes, with 40 markers, you can do a panel in 2 or 3 hours maximum. So another possibility of contamination of spillover is the oxidation, because your marker can have an oxide during the ionization, so you can have a +16 signal. And another thing is the abundance. So as you can see here, you can have like a leak in the +1 and -1 channels. So this occurs when you have really too much signal, too much antibody in one channel. So this is something that can be solved by just titration. So if you do a good titration, you will not have to care about this abundance spillover. So we will see that just after. Just before that, I want to talk to you about some of the panels that we pre-designed for you. So if you don't want to design your own panel, you can just pick into our pre-designed panel, so it can help. And for your panels, we have a catalog of a lot of pre-conjugated antibodies, but if you want to use some antibodies that are not in our catalog, you can conjugate them at your lab. It takes half a day to do a homemade conjugation, and it's super robust. You will have a 70% recovery, and yeah, there is no issue to do that. So as I said before, to prevent the main spillover, you can just titrate your antibodies. So this is a crucial step. Always titrate your antibodies and your reagent before your experiment. So you will have the best signal and you will have less spillover. So as you can see here, that for the CD8, for example, you have 3 different concentrations, and when you increase your concentration, you also increase your spillover in the channel in -1. You see here 146 and here 145, and you can see that here the signal is super low in the 145, and here it's increasing. So as I said before, if in the other channel you have something really high expressed, there is no issue because this does not impact the other channel, but just be careful. And yeah, titration is always a good thing because sometimes, so when we sell an antibody, we recommend to use it at 1 to 100 concentration. So, but sometimes you can use it with a lower concentration, and it's super cool for you because you will use less antibody at the end, and maybe 100 tests, a vial will do 200 tests or 400 tests. So yeah, always titrate. It's better for your results and better for your money too. Another thing to always titrate is your iridium. So the iridium will stain the nucleus of your cells, and it's super important to titrate your iridium to have the best results. So as you can see here, if you use too much iridium, you can have a contamination in platinum channel, for example. So if you use this channel for live dead staining, it will impact that. So just titrate your iridium, and you will see that it will be easier to just discriminate your cells. So the iridium is staining your nucleus, so it's the only way to see your cells. So if you use two less iridium, you will have like a fusion between your debris and your cells, and it will be hard to distinguish your cells. But if you use the correct concentration, you will be able to see your debris, your cells, and also your doublets. So it's something really, really crucial. Never forget that. And just keep in mind that this inconsistency in your iridium staining will not impact your results, but it will be super easier if you have always the same intensity of your signal for your gauging. And if you use too much reagent, you will have the same issue as your contamination issue we see before. So yeah, titration is something really crucial, and never avoid to do that. So some tricks for the titration: you can start at 1 to 50 for pre-conjugated antibodies and 8 microgram per ml for homemade conjugated antibodies. You can titrate a lot of antibodies. So sometimes when we say that you have to titrate all your antibodies and you have 40 antibodies in your panel, you would say, oh my God, I have to do a lot of tubes, but not. You can do a lot of titration in the same time in the same tube. So just keep in mind that it's better sometimes to split your panel in 2 or 3 tubes. It depends on the amount of marker and the marker you will use. You can limit in this way the plus and minus 1 spillover and the plus 16 spillover. Always use a parental marker if you are looking at a subset, like for example, if you want to look at the FOXP3 or CD25 on Tregs, use a CD3 and CD4 to be sure that you will look at this marker in the good population. And like this, you will also be sure that your marker is specific if you do a homemade conjugation, for example. Another thing important is always use the same number of cell and the same type of cell that you will use in your final experiment. It's really important to do your titration in the same condition of your experiment. And just be sure that your sample contain positive and negative cells for the markers you want to look at. So for the homemade conjugation, there is some tips and tricks also. So if you are doing some cadmium and lanthanide labeling in the same time, just be careful because the protocols are different. So it's better to do all the lanthanide conjugation in the first step and do the cadmium ones in the second step. For the conjugation itself, it's better to use a water bath instead of heating block, for example, because the temperature is more constant. And if you have low yield of your custom conjugation, just check your flow through and be careful to not touch the whole of the filter when you do your conjugation. And it's a little thing that you can do at the end of your conjugation. Just check your antibody on beads, like com beads. So it's super quick and super useful. So if your antibody is well labeled, you will have a signal on com beads. So For your staining samples, so as we said before, never use a sample with less than 80% variability. Of course, if you're working on tumors or things like this, sometimes it can happen that you will have less. So just talk with your core facility. Another thing, all our protocol are validating on 1 to 3 million of cells. So if you want to use more cells, just increase your volume, your staining volume and washing volume. And this can happen when you use barcoded samples, for example. Always use FC block to reduce unspecific binding. You can also use heparin if you use whole blood. If you stain whole blood, it will just block and reduce the unspecific binding. And another thing, always use a live dead staining. As you know, the dead cells will get a lot of antibodies, so it's always good to have a live dead staining. Rhodium, we have two of this live dead staining, the rhodium and the cisplatin. Both are really different. The rhodium is not compatible with methanol because there is no covalent linkage with the cells. So if you want to do phosphostaining, it's better to use cisplatin. And just be careful that if you want to use cisplatin for antibody labeling, don't use it for live dead staining. It's really. So and yes, if you want to work on fixed sample, just do your live dead staining before. So if you want to do phosphostaining and you have a stimulation and then you fix the cell before your staining, do your live dead staining during the stimulation. It could be a good point. And you just keep in mind that the rhodium is 103 mass, so you will not have any issue in plus -1 and plus 16 because there is nothing in this channel normally. So if you want to have access to our validated protocol, just go on our website. We have some protocol for surface staining, nuclear staining, cytokine, phosphoprotein. So yeah, just look at all the protocol we have. And once again, if you have questions, just ask us or discuss that with your core facility. They are just here for that, so do not hesitate to do that. So a little bit more of tips and tricks. When you finish to do your surface staining, always do a fresh fixation with formaldehyde at 1.6%. It will just link everything at the surface of your cells, and it will be better after for the acquisition. The cells will be more resistant during the acquisition, because the acquisition is done in water or cast solution that is a kind of water. So if you don't want your cells to explode during the acquisition, it's super important to do this fresh fixation with a vial of formaldehyde, so you are sure that it's fresh. Another thing, if you have really sticky samples, you can add a little bit of EDTA during the washes, during the washes prior the staining. It's better. Be really careful with EDTA because it's a chelator, and here we use antibody labeled with methyl, so it's not always the better answer, but if nothing works, it can be. And another thing, you can keep your cells in iridium, perm-fix iridium at the end of your staining up to 48 hours maximum. And the day after or 2 days after, just wash your samples with the safe staining buffer and store them as a pellet. Like this, you will not have an explosion of your cells. And yes, something really important, never skip on washes. So Sometimes you can say that, oh my God, this protocol is too long because you have to do the surface staining, then the fixation, the intracellular staining, and sometimes you may want to just skip some steps and some washes steps, and it's a really, really bad idea, because when you skip some washes, you will have this kind of results with a lot of contamination, and you will have a decrease of your signal and an increase of your background. So it's clearly not a good idea. So here you can see a decrease of the signal when you have too much background. So yeah, if you want to skip some steps, don't skip washes, please. So now, another bad reputation of the mass cytometry is the fact that you lose a lot of cells in mass cytometry, but that is not always true. It's just the fact that you have a lot of steps because you are doing the live dead staining, the surface staining, and then the intracellular staining. So you have a lot of steps, but it's the same for classic cytometry. And in this case, just be careful on some different points. So we will see that. So never decant your tubes. Always aspirate, not with pipette, but with a vacuum system. It will be more, consistent, and you will lose less. Another thing, do not use 50 ml tubes. Prefer 15 ml Falcon or 5 ml Fax tube, or even Eppendorf or plates. But yes, be really careful of the tube that you will use for your experiment regarding the amount of cells you have. Apply the right G-force that correspond to the tube you will use, the tube or plate sometime. So just adapt the G-force to that. And be careful of the time of the centrifugation. So if you, yes, the time will depend on the column of volume in your tube. So if you use a tube half full, you can run it for 3-4 minutes at 300 G, it will be okay. But if you have a full tube, just increase your time to recover maximum of cells. Yes. As you know, PBS don't contain any protein, so when you do too much washes with PBS, you will lose a lot of cells because the tube's wall will not be blocked with protein. So you will have a lot of electricity, electrostaticity, and you will lose some cells. And of course, when you do intracellular staining, you use arch-perm protocols, and there is nothing to do. You will lose some cells, but losing 50% of your cells is okay. Losing 80% of your cells is not okay. So yeah, just check at each step which amount of cells you will lose. And if you start with really a low number of cells, just consider using barcoding. So what is the barcoding? So the barcoding is a way to encode. So you will stain specifically your different samples, and after that you can pull all your samples in just one tube. So like this, you will process all your samples that are contained in just one tube in the same way and in the same time. So like this, you will have a bigger palette because you have all your samples in just one tube. So you will lose less cells at each step. So it can be a really good answer when you have really low cell samples. And after that, you will also decrease batch effect, for example, because all the staining and all the acquisition are done at the same time. So we have two different barcoding that we propose. We have palladium barcoding and a live barcoding based on CD45 staining. So if you want to have more information about that, just ask us. So you can ask a question, or you will have my email address later. So don't hesitate to just ask me. So the CD45 live cell barcoding can be done with cadmium isotopes that are not included in your antibodies for the staining. So do not hesitate. We have a poster about that available on our website. So some tips and tricks for the barcoding. You can consider to do barcoding for low cell samples, and this will improve also the batch effect and save time and save money. Save time because you will have only one tube to process and acquire, and money because you will reduce the amount of reagents to use. Some tricks, just be careful of the type of barcoding you will use, and just be careful that it suits your experiment. For the live cell barcoding, think about your barcoding scheme before the staining, and pipette your barcoding just before your staining in a calm area and things like this, just to be sure to don't do any mistake. One thing really important for the efficiency of your barcoding is to wash well just before pulling your samples. So you have to really do a good wash to avoid unspecific staining of your barcode afterward. And always remember which barcode you used, and provide this information to your core facility for after that for the debarcoding step. So for the acquisition, it will be really fast because here you just have to rely on your core facility at the EPFL. So you have to provide your samples that can be fixed only or fixed and frozen. You have to provide your panel, or at least if you don't want to say which markers you use, the panels used. But all these things have to be discussed with the core facility, and Miguel Estina will just give you the guidelines to do that, and the cost facility will just take care of your acquisition. So just rely on them. After acquisition, you have data processing. So if you have to process yourself your data, just be careful to always proceed in the following orders. Always normalize first, then concatenate if needed, and then debarcode if needed also. And the first thing to do before analyzing your data is to do a cleanup. So we have here a little strategy of the cleanup, so you can follow that. The main point is to remove bits first, and then remove the fusion of the ion clouds or doublets. So you can use the Gaussian parameter that you can see here, the residual, center, offset, and width, that are the Gaussian parameter of the distribution of your ion clouds. So if you have two ion clouds that fusion, you will have an impact in the Gaussian distribution of your ion clouds. So just use that to eliminate doublets. And then you will look on the live dead and DNA to exclude the remaining doublets. So for your data processing, the best thing to do, the analysis, the best thing to do is always check all your markers in the first step. So just to be sure that all the markers work well. And after that, just keep in mind that if you have garbage in, you will have garbage out. So if your samples was with too much debris, you will have too much debris in your analysis. So yeah, just always compare the results with your samples at the beginning. And if you want to minimize the batch effect, there is some solution, like you can see here. There are two papers mentioning batch effect and how to solve that. But normally, if you follow all the rules we saw before, you will not have any issue with batch effect. So I hope it will not be too long. So, and I hope I gave you the all keys to success with your mass cytometry experiment. And of course, if you have any question, you can contact us. So my email address is here, and you can also contact our support. or you can also contact directly your core facility. So as Miguel said before, just Google EPFL and Cytometry core facility, and yes, you will have contact. Thanks to all of you.
Thank you very much, Emily. That was a great presentation. I want to remind everybody you can keep asking your questions in the question box, which is on the right-hand side of your screen. But in the meantime, we've got a few questions, so I will ask them now. If you don't know the background of my patient, how can I know if my sample is contaminated?
Okay, so yes, it's a good question. So I would say like this: you just see with the core facility if they can test your sample. So maybe just provide a little aliquot of your sample and ask Miguel and Sena to maybe to look at it. You can do a really low concentration of your sample and see if there is any contamination before your staining. So if there is a contamination, you will not do your staining on these samples.
Thank you. The other question is, do you have whole blood staining protocol?
Okay, so for now we have only one official whole blood protocol with the MD packet. That is a kit really specific that all the antibodies are dried in the tube. So for this one, we have an official protocol, but we have a lot of recommendation if you want to use whole blood in your experiment, and there is no issue to do that.
Thank you so much. And the last question we had is how long does it take to do a self-conjugation?
Okay, so self-conjugation takes approximately half a day to do it. So I think the core facility is proposing to do that. So just see with them if you want some help. But the protocol is super easy, so you just have to follow the different steps and it will be okay.
Yeah, and if I can add something, you can also do that in the lab. You can also do that in EPFL. We have everything.
With the supervision of Sena.
Yeah, if you need.
So yeah, I think this is all the questions that we had. So thank you so much, everybody, for joining today. Thank you, Emily, for the great presentation, and Sena and Miguel for hosting us as well. I don't know if you guys want to say a little something before we stop the session.
Yeah, of course, we want to say thank you to Emily and you for this presentation. We will have more, I guess. I think you will propose more, and I also encourage people that want to present their projects. We have a small chat with the Cytometry community in Germany and in Germany, Switzerland, Luxembourg, and France. I mean the Francophone community, let's say, plus Germanophone. So if you want to present your project in front of like the Cytometry community, it's possible. You just reach out to me, and I will indicate you how to do that.
Excellent. Thank you so much, Sena. As I said earlier, if you want to book a one-to-one with Emily, there is still some space, so you can click on the link I sent in the chat. And thank you very much for joining, and I will send you the recording in a few days. And yeah, thank you so much, Emily. And if you have any question, just reach out to us. Thank you so much.
Thanks. Bye-bye.
Thank
Bye.
you. Bye-bye.
Bye-bye.
Thank you.